everybody. So now we're looking into question 22, which is essentially on hydrated salt. So there's a little bit of mole concept as well as a back to basic questions such as the number of moles, etc. So 30 marks, let's dive in. With the first question, we are having quite a lengthy formula over here, and I want you to look at the number of different elements. So to do this question, what you should be able to do is to look at this and to identify all the uppercase. Okay, so we have got I'm going to use slightly different colors so you can see it. Okay, nitrogen, sulfur, oxygen, and hydrogen. Okay, I'm not counting the last O again because these two are essentially the same type of element, which is oxygen. Okay, so there are essentially only 4 types, and that would be sodium, that's Na, sulfur, and then the O's is oxygen and H is hydrogen. So there's only 4 types of elements in there. Next question, we are looking at total number of atom in this case. So we need to count number of atom. So nitrogen is contributing 2, plus 1 sulfur, 3, and then plus 4 oxygen. So this part alone is worth the total of 7 atom. Okay, and then for water is like this. So one water molecule has 3 atoms. Okay, and because there's a total of 7 water molecule, so I multiply 7 and 3 together, I get 21 here. So essentially, if you add them up, 7 plus 21, you will get 28. Okay, right. So that's how we get D as the option. Remember to cross out your answer. Next one. We are having a setup here, use the apparatus to find the value of X. X here refers to the number of water molecule. And so this is the student's method. So they find the mass of the anti-tube, basically this one. Then they put the hydrated sodium sulfate in the tube and they heat it, and they are essentially trying to find out what is the X value of water molecule, what's the number of water molecule that's surrounding sodium sulfate in this case. Okay, so we have the first 2-mark question that asks us about describe what the student should do next to make sure that all the water is removed from hydrated sodium sulfate. This is a 2-mark question. The basic common phrase that you would definitely need in this case to get this 2 marks is heat to constant mass. So heat alone, 1 mark. To constant mass is basically your 2nd mark. What this basically means is you want to make sure at the end of the day, say for example, you start off with like 25.50 gram. After 60 seconds, it dropped to this. And then like something like that. And then you notice that no matter how long you heat, the mass remains the same. This shows that all the water molecule has been removed. So this is what we meant by heat to constant mass, is to make sure that all the water is removed. This is essentially, these 4 words here will get you your 2 marks. Okay, right? Other than that, you can think about how to describe this process, heat to constant mass, in your own words. If this 4 words here, heat to constant mass, it's a challenge. Right, next one. Explain the role of ice in the beaker. Oops, where exactly is this ice in the beaker? Take a look at the setup. So essentially, we want to put some ice over here. Okay, now what's happening here is during the process of heating, this water will actually be turning into water vapor. Right, and this water vapor, there's only one way, so it will just go in here. But you see, the vapor is in contact with something very cold, such as the ice. So what the vapor will do here is the vapor will actually be cooled, and it's actually useless if it's just being cooled, because if the vapor is cooled, it can still remain in vapor state. But if it's cooled below its boiling point, yes, then what's happened is it's going to condense and become water. So the next question here is 2 marks, and you need to hit this 2 key point here. That is, the role of the ice here is not only to cool, but to condense the vapor into water. So the word condense is important because the idea here is to turn something from gaseous to liquid state. So you need to take note of that to get your 2 marks. Okay. So just saying, like, to cool the water vapor alone will only get you 1 mark. Okay, so that's how the answers, or how the key ideas of the scientific concept is being broken down. You need to cool and you need to condense to get your 2 marks. Okay. CE, if this is the first time you're accessing my videos, the word CE refers to common error that students tend to write, and that's the reason why they either score 0 or not the full marks in this case. The wrong concept here is to keep the test tube cold. Why is there a need to keep the test tube cold here? Okay, you need to think about the bigger reason. And if you're just talking about cooling the water, is not enough, again, because the scientific concept of condensation is not being brought up here. Okay, so this might only get you 1 mark, but not a full mark. All right, next question here. I like this question. Okay, even when I first see this question, I almost got it wrong as well, because here you see, describe how the student could prove the liquid collected is pure water. A lot of students actually wrote the answers in red, which is add anhydrous copper sulfate, and turn from white to blue. The most of them write that, okay, but it's wrong. Why is that so? Because anhydrous copper sulfate here is only to test for water. It does not tell us, or it does not give us any hint if the water is pure. So this is a keyword. Essentially, in my opinion, I think this word should be bolded, to bring the attention to the students that we want pure water, not just water. Okay, so how do we get this? How do we know if something is pure water? We have to use the physical property. So in this case, we have to use a physical test. We can either heat the water, and if the water boils at 100 degrees, okay, then you know this water is pure, because pure substance have a fixed melting or boiling point or freezing point, etc. Okay, because it's water, we can also do the other way, from liquid to a solid state. We can also cool the water, and if you freeze at 0 degrees Celsius, then we know it's also pure water. Okay, so you can either use the boiling point or the freezing point to help you determine the purity of this water. Okay, next is a 5-mark question. It's also the final question here. There are only 3 values in the table above, over here. Okay, so we want to find out what is the X value, basically how many water molecules surround this sodium sulfate salt. Okay, so first you want to find out the mass of salt, so you need to use 3 minus 1, okay, because 3 would be the mass of the salt left in the tube. Okay, so 3 minus 1, essentially I'm talking about this 1, 2, and 3. Okay, and then if you want to find out the mass of water, the difference between 2 and 3 is the mass of water that's being heated off. That's 4.5 gram. So next thing here is you need to go back to your mole concept. Okay, mass, mole, MR. So the only way to compare between these two is using mole. So in order for us to find mole, our third step here is to find the mass of water over the MR of water. MR, you can use the periodic table to guide you. Okay, so every hydrogen is 1, every oxygen is 16, but because H2O, water is H2O, so it's 2 plus 16, so that's how I get my 18 here. Okay, they have also been kind. You see, they have given us the MR over here. Okay, and then next point, step number 4 is you want to find the number of mole of salt. Again, you use the mass, divide by MR as given in the question, and that will be 0.025. So think, when I first do this question, this number is like, what? Am I looking at the same number? Is the X value just 1? But it's actually is a difference of like 10 times more. Okay, so the ratio between the water to the salt here is actually 10. So what this 10 means is, if I were to put it into the formula, it would be NaSO4, Na2SO4 followed by dot 10H2O. So this salt here is actually surrounded by 10 water molecules. That's basically what this X value represents, 10 water molecules. Okay, so with that, this will be the end of the 30-mark question. It is a quite good question in my opinion, because it draws in a lot of concept, more concept, water purity. It also tests you on practical. How do you know if all the water has been evaporated? That 4 words here, heat to constant mass, is a constantly tested concept, so get used to that idea. If that phrasing is really doesn't stick with you, then try to think of your own way to describe that heat to constant mass. Okay, and yeah, and the basic questions such as what's the number of elements in there and how many atoms are in there are also included in this question. All right, so I'll see you in the next question. If you have any question, please again leave a comment. I'll be happy to guide you.